The question is to multiply the polynomials by grouping. If each of these polynomials has same expressions, in this case a minus b, then we can let a minus b is equal to capital A. So if we rewrite this expression, that is equal to a plus 1 times a minus 1, that is equal to a squared minus 1, right? Now what we have to do is we have to substitute a minus b for capital A. If we do that, then that is equal to a minus b squared minus 1. And this is a special product, right? So that is equal to a squared minus 2 times a times b plus b squared. And we have minus 1. Now we're done. Alright, in this question, we have the same expression x plus 3z in each polynomial, right? So we're going to let x plus 3z is equal to a. Then this is equal to a plus 2y times a plus y, right? And if we expand this using a FOIL method, a times a, that's a squared. A times y, that's plus ay, plus 2y times a, that's 2ay, plus 2y times y, 2y squared. And this is equal to a squared. We have ay, 2ay, so plus 3ay plus 2y squared. Now, what we have to do is we have to substitute x plus 3z for a again. So this is equal to x plus 3z squared plus 3 times x plus 3z times y plus 2y squared. And if we expand each of these expressions right here, that is equal to x squared 2 times x times 3z, that's 6xz plus 3z squared, that's 9z squared. Plus we have 3 times x times y, 3xy plus 9 3zy, so 9yz plus 2y squared. Now we're done.